Hello everyone, welcome to Electronics and Communication Engineering Department, Viviraju Institute of Technology, Narsapur. Started in 1999 and continuing its legacy with having 7 different special laboratories, which includes Center for VLSI Design, VLSI Automation, Embedded System and IoT Lab, Embedded Automation Laboratory, Robotics Center of Excellence, Advanced Communication Laboratory, and A&ML. Department is pride in receiving lot of funding from different agencies that includes SERB, AICT and as well as DST. So department is procured with lot of advanced simulators which includes Xilinx IDE, Synopsys, TCAD and as well as ARM advanced boards which includes Zinc and as well as Ping boards. Faculty and student cumulatively work on developing lot of prototypes, maintaining the moderate TRL levels which have been submitted to lot of project competitions which includes L&T TechGM, STM Innovation Challenge and as well as ISTOSTAT. So we have pride associations with a lot of pioneers in the field of semiconductor technology and as well as 5G technology. Welcome you all to the antenna testing laboratory. So we basically have 3 major operations that we carry out here. One is the design part, the implementation and as well as testing of the antenna modules. So to begin with the design part, we try to list out the design considerations of the antenna module that includes the size of the antenna, length, width and as well as the frequency of its operation. Depending on the operations, we try to execute the design part. Followed with, we will move on to the implementation part. So we preferably take the ANSYS HFSS toolbox for generating the simulation results. So we deploy with what sort of feeding mechanism that we have to import for the antenna modules that we have designed. So that design can be included in lot of applications. So when we try to implement, we come out with generation of lot of parameters that has been generated for the antenna module. Then in the third step, we try to apply it for the experimentation part. So we depend on vector network analyzer. So we try to develop the antenna module that has been interfaced to the vector network analyzer and see that it is meeting the right criteria of operating frequency or not.
This particular facility is called as anechoic chamber facility, and the main objective of this facility is to have the measurement and as well as testing results that are generated for different wireless modules like antennas and as well as sensors.
Hi, my name is Gnaneshwarachari. I am the coordinator for Center for VLSI Design. This is the lab which is built for the ASIC design. ASIC means application specific integrated circuits, where we can design the total IC. So that IC designing totally we can complete by using this lab. Okay, here we have the Synopsys tools, Cadence tools, Mentor Graphics tools, and also we have the ANSYS tools for packaging. We are working on advanced level packaging like a chiplet packaging. It's called the heterogeneous packaging. We have tied up with the Penn State University.
Okay, welcome to Center for Embedded Systems and IoT Lab, ECE department. This lab was established in the year 2014. So nowadays, embedded system and IoT is a buzzword where everyone hear about it. Coming to the embedded systems, the 99% of the electronic goods what we use today are embedded, and in future, every house appliances, either industry or any health sector, everything else will be connected to internet so that it can be controlled using remotely anywhere from the world. So these plays a crucial role in the today's technology. Coming to the core structure of this embedded system IoT lab, we train the students in different boards such as ARM Cortex M3 processor, Raspberry Pi boards, as well as Node MCU boards, TA MSP430 boards, and TA CC300 boards for embedded and IoT applications.
So in this QNX is a division of BlackBerry Private Limited. So like it is going to work on embedded real-time operating systems. So in the QNX as like more than 255 millions of automotive cars that we are using today are using this QNX RTOS. So the QNX RTOS is based on the microcanal architecture, and we are going to work on the timers as well as inter-process communications like messages, queues and semaphores, IPC communications. All these methods, resources messages are being used in this QNX RTOS.
Welcome to RCL lab. So this is our robotics lab where we actually do projects in robotics area which are applicable for medical, agriculture, industries and lot many. So these are some prototypes designed by our students. This is our team, Shravani, Anil sir, Rajesh sir and Prabhakar sir is the coordinator. So we all guide the students under the areas where they can actually apply microprocessor controllers under Arduino, Raspberry Pi and lot many. So under these softwares and hardwares, they'll know how to build a prototype, and most especially our RCL lab is a multidisciplinary, where we have all the students from ECE mainly and EEE, BME and mechanical as well. So we have the students knowing to cut the product, to make the product manufacture, to learn it through the coding as well as all the skills. So communication, coding and mechanical things are performed here. So under this we have a lot many MOUs with different robotics companies, where the company persons and resource persons come and train the students whenever we require for the industrial purpose prototypes. So in this way the students participate in hackathons and lot many contests, and all over India they have been participating and giving their prototypes to get exhibited all over. Recently we had in IIT Madras also, where our previous students have developed a smart band for pregnant women. That was most good product among them, and that was selected for the IIT Madras contest also. Recently in MSME also they have been submitting the products and lot many projects under agriculture, drones and robotic applications in medical and healthcare. So this is robotics lab. Thank you.
Hello everyone, this is Dr. Jayashree. I am coordinator for this Vishnu Space Engineering Center. This is the ground station, Earth station, which is technically called as a VHF ground station. This facility is used for tracking the low Earth orbit satellites, LEO satellites. All the telemetry data transmission and reception can be possible from this ground station. All the public satellites can be tracked from this ground station, which are publicly available. For the tracking of this ground station, we have a customized software. For testing the efficiency of this ground station, we have conducted the experiment called as high altitude ballooning experiment. And in this experiment, we have conducted this experiment at ECIL, at Tata Institute of Fundamental Research, TIFR, in the morning 5 to 6 o'clock of window, and BVRIT students and the faculty were part of this launch. So this is the helium balloon. If you are able to see, this helium balloon was launched early morning 6 o'clock. Along with this, a payload is attached. So this is the payload, where we have a small camera. This camera is attached with this balloon and used as a payload. And the tracking of this is possible, and we have successfully tracked this balloon, and this is the tracking path which is shown here on the screen. Thank you.
Welcome to NVIDIA Center of Excellence in Artificial Intelligence and Machine Learning Special Lab in ECE Department at BVRIT Narsapur. I am Dr. I. Krishna Pawan, heading this special lab. Our special lab main focus is on applying current AML techniques for smart grids, autonomous vehicles, computer vision and speech processing. Our lab is equipped with high-end workstation with NVIDIA GPUs and Jetson nanobots and Jet Racer Robocar. Okay. Yeah, our students have excelled in many international national competitions conducted by industries like L&T and academic institutions like IITs, NITs and IIITs.
I welcome you to the Embedded Automation Lab, which was equipped in the Department of ECE, BVRIT. So in the second year of engineering, students will be entering into this lab, where they will be trained on different tools here. So on the basic embedded platform tools, as well as the tool that has been sponsored by the National Instruments, what is called as LabVIEW. So once the student gets trained in this particular tool, so they will be practicing some basic experiments, and they will be continuing with their final year and third year projects with this particular tool. So the lab is also equipped with different hardware units which are from the National Instruments.
So here this lab is equipped with different hardware tools of National Instruments along with the embedded processors. So here we can see this is the NI camera, which was designed by NI. So that is a National Instrument company, where we can find out like the examples of coin sorting. So those kind of tiny application or image processing application kind of thing, we can use the NI camera. Next, this is one of the Danny robot where we can use it for the path planning kind of application. So we have the Myrio component. So this is it is a combination of both FPGA along with the processor. So where it is one of the compact device where the student can build the applications and they can interface the virtual environment with the real time environment. And along with that, student can develop their experiments on the LVs. So these are the two different versions of the tools, LVs 2 and 3. Along with that, we have some more equipments, the lab where we have, so that is one of the PXI system. Along with that, we have some more like embedded processor. Along with that, we have Arduinos and Raspberry Pi devices. Thank you.
Myself, I am Dr. Divyavani. I am the coordinator of this VLSI automation. And in this lab, we'll be working on the RTL designing part, and the students here will be working on the automations by using of the robots. And we have the different kinds of Xilinx vendor FPGA boards we have. And from this lab, many of the students have been working in the good institutions like Synopsys and BitSilica, and few of the students have also got internships in the Qubit.
Hi everyone, myself Dr. Mudassar Basha. I am the member of this VLSI Automation Lab. Basically, I work on this mobile robot application using FPGA technology. So basically, this lab is completely related with FPGAs, field programmable gate arrays. So we have different kinds of field programmable gate arrays purchased or procured from Xilinx. So starting from Z board, Nexus 4 DDR, Pink board, Kriya board, and we have also Pink basis FPGA boards. So basically these FPGA boards are very high programmable and complex programmable devices where we can work on with embedded hardware as well as software applications. So we can completely design embedded as well as software co-application using these FPGAs. So basically this FPGA programming, we use these FPGA technologies to for a certain application called mobile robotics, and this is the mobile robotics which we have developed in our lab, and the students are most of the students are working in this robotic application using image processing and sensor fusion technology.
Hello everyone. So apart from this robotics, even with this robotics, MEMS technology also been work is done by students. MEMS is nothing but micro electromechanical systems. So by enhancing the switch RF MEMS switches, we can use these applications in various satellite communication filters by the up capacitance, down capacitance, insertion loss parameters. So with this in communication system, we can enhance the outcomes.
Looking forward for a lot of quality projects and as well as competitions from the students. Thank you.